tends to A. How to read this? X tending towards A, or you can say X approaches to A. It means X is not exactly A. X is approaching towards A. X tending to A gives us, okay, gives us fx tends to L. Okay, if X tending to A gives us fx tending to L, then mathematically how to write this statement? So mathematically we write this limit x tending to A, f of x equals to L. This is the meaning of limit. And first of all, when we say limit, whatever answer comes in limit, that is not exact answer, it is approximate answer. Okay, suppose any times limit value came 2, then it is not exactly 2, it is approaching to 2. It means it may be 1.99 something, or it may be 2.000, very close to 2 but not exactly 2. So whatever answer comes in limit, those answers not exactly, they will be approximate answers. Okay, then here x tends to A means x approaches to A. Okay, x approaches to A. Now suppose this is a number line, and here take this element A. Okay, and I have said x tends to A means, x arrow A, how to read? X tending towards A, or we can say x approaching to A. Now you tell me, how can we approach A? A obviously on the x-axis, it is x-axis. Then we can approach A two types, either left from A or right from A. On the number line, right means we can approach A this way, correct? Or we can approach A this way, okay, this way. So then in the limits, there will be two terms, L.H.L, R.H.L. L.H.L means left hand limit, R.H.L means right hand limit. Okay, so when I write L.H.L, left hand limit, it means I am approaching x from the left side. Okay, I am approaching x from the left side. So it means in L.H.L, what will be x value? X value will be A minus H. Okay, what is H? H is very small positive number, infinitely small. H, very small. And what about R.H.L? In the R.H.L, I will approach x from the right side. So it will be, x value will be A plus H. Okay, where H infinitely small but positive, okay, positive number. Notations. Now for left hand limit, L.H.L, how many notations are there? Okay, up to 12th level. Okay, I will not go in higher mathematics, but up to 12th level, what are the notations for L.H.L? Suppose if I write limit x tending to A minus fx, then automatically understood I have written L.H.L. Okay, because A, we are approaching the limit A from the left side. So this A minus from upside, little minus is there, na? This minus means we are approaching limit from the left side. It means like this. This was the number line. This is number line, and here A. It means I am approaching from the left side. This is one notation. Or in the sum books, they write like this: limit h tending to 0, f of A minus h. It means when we replace x by h, when we do entry of h, then h is very small. So h tending to 0, then only it is very near to A, na? Correct. So this also left hand limit. Then what about right hand limit? In the right hand limit also two notations. So one will be limit x tending to a and positive. A positive means just positive meaning is right hand limit. Okay, approaching a from the right side, fx, or limit h tending to 0 f approaching a from the right side. It means this will be somewhat a plus h and here somewhat a minus h, so automatically a plus h. So either use this or this, no issue, either you can use this or this. Okay, then when we say limit exists, because always limit not exist, when we say limit exists and when we say limit does not exist. So if your LHL equals to RHL, LHL RHL both are equal, and equal means, and both must give finite value. LHL equals to RHL equals to L. What is L? Finite value, not infinite. Finite value. Then we will say limit exists. Okay, that is whenever limit x tending to a minus fx equals to limit x tending to a positive fx equals to L, and L is what? A finite number. Then we will say limit exists. Okay, and we can also write this notation: limit h tending to 0 f of a minus h, limit h tending to 0 f of a plus h equals to L. Okay, and L should be finite. Okay, finite. So then limit exist. Okay, no, then limit exists. So till now we have just covered notations of limits. You can combine those also. In some books you see this notation also. Here, yes, some are writing like this also: limit x tends to a fx equals to L. At first slide. Okay, first one. If this means this equal and equals to L. So in short we can say limit x approaches to a, value is L. Limit exists and its value is L. So we can combine final, we can write this also. Okay, clear? Next, let's understand through some examples graphically, because when we show graph then things are more clear. Visualization. See, this is a graph, and you can see if I say this point is A, okay, corresponding point is A. Okay, this point is A, and corresponding to this, here give some value, let's say L value. Okay, can you see this graph? In this graph, if I ask you limit at x equals to A, okay, if I ask, tell me limit at A, what is the value of limit at x equals to A? Then see graphically, you will approach A from the left side. Okay, it means suppose you are approaching left side A, you are somewhat here. Okay, whenever you are left to A, okay, very close to left, then where is your graph is somewhat here, correct na? And corresponding to this value is L coming, we can see L only coming, correct na? It means from this graph we can see left hand limit is L graphically. So from here we can write limit x tending to a negative fx, this value is L. Now let's see from right side. Approach A from the right side, then you will approach from this side. Okay, suppose you are here, then corresponding to where is graph, again is this graph, and corresponding to this what is value, join here, again it is coming almost L. So you can say from here limit x tending to a positive fx equals to L, and L is a finite number here. It means left hand limit and right hand limit both exist and giving answer L. We have just a small gap, very only one gap here. So it means if you can ignore the gap, If the gap is ignorable, then we can say limit exist. Then we can say limit exist. So suppose if I extend this graph, for example, let's say this is here, and then now, and this point let's call B point. This is, let's say, B point. Now if I ask what is the limit at B, you can see graphically, can you ignore this much gap? This much gap is not ignorable now, because in that infinite points are there. But in previous situation here, only one point is left. Only one point is left. So that we can ignore. So if gap is ignorable, then limit exists and finite here. But here in this situation at B, the gap is not ignorable. It means at B, this limit not exist. Why not exist? Because when you approach limit from the left side, for example, left side, then your function's limit value will be here. We can say this is suppose L1. Okay, and when you approach from the right side B, then your graph is here, exactly here. Then what is the value? Different. You can see, suppose this is L2. It means left hand limit gives different answer, right hand limit gives different answer. So because the gap is too much, it is not ignorable. It means limit does not exist here. Okay. At x equals to a, limit exists. Okay. And here limit x tending to b negative fx, this value is L1, and limit x tending to b positive L2. Since limit L.H.L not equals to R.H.L, so limit, okay, does not exist. Okay, just for understanding, if I make any rough graph here, suppose this, and here the graph is like this. Okay, can you tell me at ABC, at A does limit exist or not? At A does limit exist? Can you ignore that gap, small gap? Okay, so at A limit will exist, correct, because it is ignorable. This gap is ignorable. What about B? Limit does not exist here. Okay, what about C? Yes, you can ignore this gap. Okay, so understand. आगे समझ. Next, important point. Okay, we will check L.H.L, R.H.L. Okay, if your point at which you are checking the limit is between the domain of the function. Okay, next point is we will check, okay, L.H.L equals to R.H.L if x equals to a point is in between domain of fx. Domain of fx. What do I mean by this point? Okay, through example I will explain. Suppose I am giving one example. I am saying find limit x tending to 1 cos inverse x. Okay, cos inverse x. Find limit x tends to 1 cos inverse x. Now you already know what is the graph of cos inverse. Remember graph of cos inverse, so like this. Okay, here -1, here +1. Okay, and here I am asking check the limit at 1. And what is 1? 1 is not in the between of -2 1 to 1. 1 is at the end points. Now can you answer my question? I am saying we can approach 1 from the left hand side. Correct, we can approach 1 from the left side. It is possible from this side, but can you approach 1 from the right side? Because right side of 1 graph is not available. That is the meaning of the point. We will check L.H.L and R.H.L equal if your point at which you are checking the limit is between in the domain, anywhere, here, 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 anywhere. But if your point at which you are checking the limit is any of the end point, then we will check only those limit which is available. Here left hand limit is available, but right hand limit is not available. So right hand limit we will not check, but left hand limit we will check. So in that, first of all I will check left hand limit. How to check left hand limit? How to write left hand limit? Limit x approaches to, what is happening? X approaches to 1 minus fx. If I remove this x, I want entry of h. Then how can I write? I want to entry of h. Then limit h tending to 0, I can write f of 1 minus h. Correct, no? 1 minus h. So limit h tending to 0. Then in the function, I have to replace x by 1 minus h. What is function? Function is cos inverse x. Then I should write cos inverse x means 1 minus h. Now I can put the limit h value 0. Then what is answer? Cos inverse 1 minus 0, cos inverse 1. And what is cos inverse 1? 0. 0. And if you ask for right hand limit, okay, not available. Okay, not available. Okay, so don't check. You don't write like this, so don't check. Let's understand. Okay, do not check. Do not check. Only left hand limit we will check. So what is the answer of the here? It implies limit x tending to 1 cos inverse x is 0 is the answer. Is this point clear? Note. So whenever the point is end point, we will check whatever limit available. If I ask you what is the limit at -1, then that time right hand limit available, left hand not available. Then we will check right hand limit. Okay. From here you write remark. Okay, remark. If x equals to a is end point, then we will not check both L.H.L, R.H.L. Okay. We have to check whatever available. Okay, next. Indeterminate forms. Okay, next is indeterminate forms. In the mathematics, 7 indeterminate forms. What are those forms? After putting the limit, if your answer came 0 to the power 0, you are knowing anything power 0 always 1, but 0 power 0 is not 1. It is something we don't know. Nobody knows in this universe. Nobody knows. 0 by 0, one of the indeterminate form. 0 0 cancellation not allowed in numerator and denominator. It is indeterminate. Next is infinity minus infinity. is one of the indeterminate. Infinity by infinity is one of the indeterminate form. Infinity power 0 is one of the indeterminate form. Huh? One. Any finite power 0 is 1 except 0 and infinity. Okay, 1 to the power infinity is also indeterminate. Okay, it is in the limits there are some boundations. Okay, infinity power 0 is not 1 in the limits. Okay, and here it is not exactly 1. If exactly 1, then it is 1 only. In the limits it is not exact number, it is approaching to 1. So 1 power infinity is also indeterminate. 0 into infinity is also indeterminate. Note 7 indeterminate forms. Some basic things. What basic things? If I ask you what is value of infinity plus infinity, okay, tending to infinity, okay, infinity plus infinity is also approaching to infinity, because infinity is very very large, something very very large plus again very very large. So after adding infinity, but in the minus, because infinity you don't know, then how will you subtract? Okay, that's why that is indeterminate, but this is determinate. Okay, no, this is first. Second one is a upon, okay, a upon 0. Anything upon 0 is infinity, but a should be finite, where a is finite. Okay, anything upon 0 coming infinity. Okay, now 0 power infinity, 0 power infinity, tell me, is it indeterminate or not? 0 to the power infinity. If I ask you what is 2 power 2, you will do 2 into 2. You will do 2 into 2. So power basic rule means those many times multiply. So 0 power infinity, it means 0 into 0 infinite times. It means this is not indeterminate. This will be 0. Okay, but infinity power 0 is indeterminate. A number between -1 to +1 to the power infinity. Okay, a number between -1 to +1, a number between -1 to +1, its power infinity, what is the answer? 0. Okay, 0. For example, if I ask you from here, for example, if I ask you what is the value of 0.992 power infinity, answer is 0. If I ask you what is the value of 0.5 to the power infinity, 0, because it is less than 1. So less than 1 but greater than -1. A number between -1 to +1, power infinity is 0. Okay, if I ask you what is the value of 2 by 3 power infinity, 2 by 3 power infinity, 2 by 3 less than 1 power infinity is 0. It is 0. If I ask you what is -1 by 3 power infinity, 0, because -1 by 3 is also between -1 to +1. Okay, between -1 to +1. Okay, then a number greater than 1, okay, GREATR, greater than 1 to power infinity is infinity. A number greater than 1 to power infinity is infinity. See, these things you must know, otherwise you can't survive. Yes, you can't survive in this chapter. This chapter you go like anything. And these are basic things, okay, in maths. Okay, everybody should know. If any number between -1 to +1 whose power infinity, answer 0 comes. Any number greater than 1, Power infinity, answer infinity. So if I ask you here, write some examples. What is 1.1 power infinity? Hello? Answer? Infinity. Okay. Pi power infinity. Pi power infinity. Because value of pi means 3.14. It means same as 3.14 power infinity. Infinity. What is e power infinity? What is the value of e? ಗೊತ್ತಿಲ್ಲ ಏನು ಗೊತ್ತಿಲ್ಲ e means 2.718 approximate. E is also irrational. Its value approximately 2.718 power infinity, because this number greater than 1 infinity. Huh? No. There is different way. Yeah. ಇಲ್ಲ in my watch still time is there. 3 minutes are there. Note quickly. Note point. ಜಾಸ್ತಿ ಮಾತಾಡಬೇಡ. Okay, inside this example also note. Okay, for your understanding, because when you read notes, when you revise notes, you will recall this all these things which I discussed. Exact zero. Okay, because in the limits exact what is very important. If I say exact one means it is one only, and arrow zero means tending to zero, approaching to zero. So exact zero upon tending to zero, what should be answer? Tending to zero means I am saying 0.00000001, very small. So it is what? Zero upon a positive number or non-zero number, zero. So exact zero upon tending to zero, answer is zero. Infinity, power infinity. Infinity. Okay. Infinity, power infinity is also infinity, tending to infinity. Infinity into infinity. Infinity. Infinity plus infinity. Infinity. Okay. Okay. Infinity into infinity. Infinity into infinity. Infinity. Okay. Infinity into infinity, we know its value go towards infinity. Okay. Then remember, uh, infinity, power infinity is going to infinity. Okay. After that, a upon 0, where a is finite number, is what? Infinity. A upon 0, where a is a finite number, it is also infinity. Okay. Then exact 1 to the power infinity. Exact 1 to the power infinity. Listen, out of 7 there is an indeterminate form called 1 raised to infinity, but this is in the limit, because I told in the limits whatever the answer, that answer is approaching to 1. So approaching to 1 power infinity is indeterminate, but exact 1 power infinity is 1. Okay, because exact 1 it is not 1 into 1 into 1 into 1. No matter how many times you multiply, your answer is always 1. But in the limits 1 power infinity, after putting the limit, if your form coming 1 power infinity, that will be indeterminate form. Clear now? Difference. Okay, then I will write some forms and you will tell me which of them are indeterminate. Which of the following question, which of the following are indeterminate forms? Okay, first one is limit x tending to 2 x squared minus 4 upon x minus 2. Second one is limit x tending to 0 plus greatest integer of x upon x. Number 3, limit x tending to pi by 2 greatest integer of x to the power 10x. I have written three problems. Okay, you have to tell out of these three problems which is indeterminate form. Indeterminate means after putting limit you should get 0 by 0 form. Suppose if you put here x value 2, then it will be upside 0 by 0 coming now. It is 0 by 0 form. 0 by 0 form. And 0 by 0 form is what? Indeterminate. So yes, this is our indeterminate form. Okay. Now put here limit. When you put x 0 plus, what is the meaning of 0 plus? 0 plus means right hand limit. Right hand limit at 0. And whenever right hand limit at 0, it means if we do entry of h, if I write limit h tending to 0, then x will be replaced by x plus h. I mean 0 plus h. If I write s tending to 0, okay, then x can be this replaced by at 0 now we are taking 0, so x will be replaced by 0 plus h. If it is left hand limit, then x will be replaced by 0 minus h. So x value means 0 plus h upon 0 plus h. Okay, now tell me what is 0 plus h value? Greatest integer of 0 plus h. H is not negative, h is very small positive number. So it means suppose 0 plus something like this, 0.0000, okay, 001. Its greatest integer is 0. It means upside 0 upon 0 plus h is h, and limit is still h tending to 0. Now do not put h value 0. Okay, when we put limit, firstly we will simplify. How much we can simplify? Still we can simplify 0 upon h is 0. It means limit h tending to 0 is 0 and it came 0. It means this is not indeterminate, because find after putting limit finite answer came, so it is not indeterminate. So no, this is not indeterminate form. First is indeterminate, second is not indeterminate. What about this x tending to pi by 2, greatest integer of x power 10x? It is what? Greatest integer. Okay, box function means greatest integer. If you put direct limit, direct pi by 2 means how much? Pi by 2 means how much? Not 90. Pi by 2, how much value in decimal? Pi is 3.14, 3.14 upon 2, approximate 1.57. 1.57. Okay, what is greatest integer of 1.57? 1. Okay, exact 1 actually, exact 1. So when you put limit, limit x tending to pi by 2, it will be exact 1 and 10 pi by 2. What is 10 pi by 2? Limit x tending to pi by 2, exact 1, exact 1. It is exact 1 and 10 pi by 2 is infinity. So exact 1 power infinity 1, because 1 multiply, exact 1 means 1 multiply infinite number of times. Answer is 1. So it means this is also not the indeterminate form. Okay, so answer is what? No. Okay, no. If limit n tending to infinity, okay, n into 3 power n divided by n into x minus 2 raised to n plus 3 n into 3 power n plus 1, n into 3 power n plus 1 plus 3 power n equals to 1 by 3. Then find range of x, range of x. Okay, range of x. Correct, range of x. Okay, this problem is of limit and very good problem, one of the ultra level problem. Okay, now see this limit value, limit value already given. Okay, after this evaluating limit is coming 1 by 3. Then what should be the range of x? Okay, what should be the range of x? Now observe the answer. Answer came 1 upon 3. Okay, and numerator part is n into 3 power n. Suppose if you put direct limit, then here 3 power infinity, but 3 power infinity is infinity, because we know that a number greater than 1 power infinity is infinity. It means anyhow we should cancel this, and we should cancel n also. So first approach, first step in my mind, that we have to take common from the numerator n into 3 power n, then cancel and numerator 1. So first step, n into 3 power n, from denominator take common n 3 power n, then we will cancel next step. So when we take common, what is remaining in denominator? In this term, n already common, correct? 3 power n not there, so we can write x minus 2 upon 3 whole power n. Are you clear? Because 3 power n not there, na? So 3 power n minus n 3 upon n and whole. I just combine. Next step, n common, 3 power n common, only 3 remaining, correct? This step, 3 power n common, it means 1 by n equals to 1 by 3. Now we can cancel this and this. Okay, this and this. Whenever n approaches to infinity, what is 1 upon n? 0, because 1 upon infinity 0. It means this term is also approaches to 0, and we want answer 1 upon 3. Already numerator 1, okay, and denominator 3 here, we want 1 upon 3. This term is 0, so it means this term has to be 0, correct na? So what we want limit n approaches to infinity, this term x minus 2 upon 3 whole power n equals to 0. Now put the limit, then it is x minus 2 upon 3 power infinity is 0. Okay, and when power infinity coming 0, if your value between minus 1 to 1, okay, we discussed now in basic things, if your number between minus 1 to plus 1, then power infinity answer 0 comes. So it means x minus 2 upon 3, this number should be between minus 1 to plus 1. Now we can solve and we can get range of x. Multiply with 3 both the sides, it will be minus 3, x minus 2 and plus 3. Add 2 on all the sides, minus 3 plus 2 minus 1, x and plus 5. So x from minus 1 to 5, and this is the range of x. It implies range of x, okay, minus 1 to 5. See, done. The natural problem arises that when we have to apply L.H.L and R.H.L, do we have to apply always L.H.L and R.H.L? Why? Do we have to find always L.H.L R.H.L? Okay, answer is no, not always, only in 6 functions. Okay, what are those 6 functions? No, only in 6 functions. Okay, what are those functions? I will write sequence wise, otherwise you might be confused. So let me write from the notes. Okay, so only six functions. First one is, do you know what is this function? Greatest integer function, GIF. This is what? Greatest integer function. Do you know other names for greatest integer function? Floor function, step function, because its graph is like steps. First step, second step, third step, up to infinity. Second one is this function. Do you know this? Not signum. It's not signum. Fractional part function. It is what? Fractional part function. Fractional part function. Okay. Here explanation not required, only you need to know. So note with me. Okay. This 6 functions. Number 3, mod function. Okay. Modulus function. Number 4, signum function. Okay. Signum function. Number 5. Okay. Number 5, piecewise function. You know, piecewise function. You have done the so many problems in exercise 5.1. Okay. In that, whenever x less or equals to 1, function this. Whenever x greater than 1, function is that. So that is called piecewise function. Okay. Or defined function. So function of this form, suppose x square plus 1, whenever x greater or equals to 1, x minus 1 when x less than 1. So this function called piecewise functions. Okay. Piecewise functions. Okay, whenever piecewise function, we have to do L.H.L and R.H.L. That's why we have done always L.H.L, R.H.L in those problems, piecewise problems. Number 6, fx. This type, 1 upon x type, okay, 1 upon x square, 1 upon x cube type, okay, such function are very rude because they always not defined whenever x becomes 0, okay. Then such function 1 upon x, 1 upon x square, 1 upon x cube, or something like that, okay. Similar functions. Note, these 6 functions we have to apply. Okay. In fact, for the better understanding, you can write x plus minus a. X plus minus a, because at a it is not defined. Whenever x is minus a, it is not defined. So 1 upon x plus minus a, so a is 0, then 1 upon x square, 1 upon x cube type. Okay. Such functions. Note. Noted? इसको कुछ नाम देने? This function. Can we give some name for this such function? Root function. Root. Okay, this is just unofficial name. Root means रूठा हुआ. Okay. Root function. So whenever this function, we have to do L.H.L and R.H.L. Okay. Find limit x tends to 0 e power 1 by x. Okay. E power 1 by x. So shall we do here L.H.L, R.H.L? Yes, because root function here 1 by x is there, na? Whenever 1 by x at 0, it is not defined. So we have to do L.H.L and R.H.L. Do L.H.L and this side R.H.L. Okay. So L.H.L means limit x tending to 0 minus, okay, fx. Okay. R.H.L means limit x tending to 0 plus fx, and fx is what? E power 1 by x. So I can directly write e power 1 by x. Okay. E power 1 by x, e power 1 by x. Okay. And whenever L.H.L, what is the value of x? X value is 0 minus h in L.H.L. And in R.H.L, what is x value? 0 plus h. Okay. So I can write e power x, I can write 0 minus h, because I have replaced x by h, then limit also of h, then limit is also of h. So limit s tending to 0. Correct. So limit h tending to 0, e power minus 1 upon h. Okay, now we can't do anything, we have to put directly limit. So when we put limit, e power minus 1 upon 0, and 1 upon 0 is infinity. So e power minus infinity, what is the value of e power minus infinity? 0, because e what? E power infinity comes infinity. And can we write like this, 1 upon e power infinity? Yes, we can write. And 1 e power infinity is infinity. So this is 1 upon infinity and this is 0. So always remember, a number greater than 1 whose power minus infinity is 0. A number greater than 1 whose power infinity is infinity. Similarly, solve here. Limit h tending to 0, e power 1 upon 0 plus h. Now put limit, put limit direct. Then it will be e power 1 upon 0. I say, because limit is 0 and 1 upon 0 means infinity. So e power infinity and e power infinity infinity. Why? Because e means what? 2.7. Any number greater than 1, power infinity is infinity. So here L.H.L is 0, R.H.L is infinity. Are they equal? No, it means that limit is not defined. Okay. Since L.H.L not equals to R.H.L, so limit is not defined. Okay. Value of limit x tending to 0, 1 plus 2 power 1 by x whole power minus 1 is equal to I can say here 1 by x and limit x tending to 0. So direct putting limit not defined. L.H.L R.H.L required. Okay, L.H.L R.H.L required. Do L.H.L. Limit x tending to 0 minus, in L.H.L 0 minus, correct? 0 minus, then function is 1 plus 2 power 1 upon x whole power minus 1. Okay. In L.H.L, x value means 0 minus h whole power minus 1. Because I replace x by h, so limit is also of h. Then limit h tending to 0. Okay. Now it is can we put limit direct? Here h value 0, then it will be 2 power minus infinity, and which is 0. We can put limit. Put limit 1 plus 2 power minus infinity whole power minus 1. And now we know a number greater than 1 whose power minus infinity is 0. Okay, so this is 1 plus 0 whole power minus 1. So 1 power minus 1 is 1 only, because 1 upon 1, so 1. So left hand limit is 1. Now check right hand limit. Check right hand limit, R.H.L. Okay, right hand limit means limit x tending to 0 plus 1 plus 2 raised to 1 upon x whole power minus 1. Okay, then limit h tending to 0, 1 plus 2 power 1 upon 0 plus h whole power minus 1. So limit, put limit, then it will be 1 plus 2 power 1 upon 0, 2 power infinity whole power minus 1. Okay, 2 power infinity is infinity, infinity plus 1 infinity. Okay, it is 1 plus infinity whole power minus 1, so infinity whole power minus 1, it is 1 upon infinity, and 1 upon infinity 0. L.H.L 1, R.H.L 0, both are unequal, it means limit does not define. Okay, since L.H.L equals to R.H.L not equals to R.H.L. Okay, therefore limit does not exist. Okay, limit does not exist. What? Limit does not exist. Limit x tending to 0 plus here written 0 plus, okay, is equal to is equal to dash question mark. Can you see any special thing? 1 by x, 1 by x, okay, it means L.H.L R.H.L required, L.H.L R.H.L, okay, but here also e power 1 by x, e power 1 by x, L.H.L R.H.L required, okay. In this problem I will tell you some good things, you can say these are the secret rahasya, okay. So here you should know some secrets, you can say rahasya, okay. Secret number 1, so many rahasya I given, okay, in that also. Rahasya number 1, whenever your limit x tending to 0 and e power 1 by x in numerator and denominator, okay, whenever limit x tending to 0 e power 1 by x in numerator denominator both, like in this situation, immediately take common, okay, take common and cancel. Secret number 2, secret number 2 is limit x tending to 0 e power minus 1 by x, then never take common, because after putting limit e power minus infinity it will be 0, okay. In numerator denominator do not take common, okay. ऐसी गलती मत करना कॉमन लेने की, do not take common. So these are the 2 secrets, okay, keep with you, don't tell anyone. Now we can start the solution, okay. Solution, look after that note, it is 0 plus, 0 plus means RHL, correct na? It means in this problem we are calculating right hand limit, okay, right hand limit. In the right hand limit what is x value, x value, limit at 0, so it will be 0 plus h. It means we can write limit h tending to 0 and x can be replaced by 0 plus h, and 0 plus h means h only, because 0 plus h is h only. So it will be h e power 1 by h upon 1 plus e power 1 by h. Now are you not looking the situation, h tending to 0 e power 1 by h, e power 1 by h, numerator denominator, apply secret number 1, take common from numerator denominator, cancel, okay. So limit h tending to 0 e power 1 by h into h upon e power 1 by h common and bracket here e power minus 1 by h plus 1, correct now, because here e power h not available, e power 1 by h, so e power minus 1 by h will come, then cancel this term, cancel by this, okay. Now put limit h value 0, 0 upon e power minus infinity plus 1, so 0 upon 0 plus 1, 0 upon 1 which is 0, it means the answer of this is 0. Note, it is rahasya. Limit x tends to 0 e power minus 1 by x upon 2 plus e power minus x by x is equal to, okay, this you try yourself students, you try yourself, okay, this problem you try yourself, Now again I am writing one ultra level problem. Okay. Slowly, your level is going to be up, or you want here only, on the first only. You don't want to go us. First of all, don't make noise. Limit x tending to 0, 1 plus a power 3, bracket close, plus 8 e power 1 by x divided by 1 plus 1 minus b power 3 e power 1 by x, okay, equals to 2. Then find AB. Okay, then find AB. Yes. First thing, 1 by x here, 1 by x. So we have to do L.H.L, R.H.L. Okay, first thing. Secondly, e power 1 by x, e power 1 by x. We will take common and cancel. L.H.L, R.H.L here required. So do L.H.L. For L.H.L, limit x tend to 0 minus, okay, and then function value 1 plus a power 3 plus 8 e power 1 by x upon 1 plus 1 minus b power 3 e power 1 by x. LHL I will do, and given 2 also, so equal to 2 will go in LHL also. If limit exists and limit value 2 given, it means LHL is 2, RHL is 2, correct now? So equals to 2. It implies that if we replace x by 0 minus h, if we replace x by 0 minus h, then limit will be like this. Limit h tending to 0, 1 plus a power 3, okay, plus 8 e power 1 by 0 minus h. It will be minus h, e power minus h upon 1 plus 1 minus b cube e power 1 by minus h. Now my secret number 2, whenever h tending to 0, e power minus 1 by h, do not take common, direct put limit, okay, equals to 2. Then I can put direct limit. On putting limit, I will get 1 plus a cube plus 8 e power minus infinity upon 1 plus 1 minus b cube e power minus infinity. E power minus infinity 0, it means 0 into 8 0. So from here we will get 1 plus a cube plus 0 upon 1 plus, this is 0, 0 into anything means finite quantity, okay, 0 because b cube is obviously finite na? So this into this 0 equals to 2. From here 1 plus a cube equals to 2. Then from here a cube, 2 minus 1 is 1, and from here a value is 1, real value is 1, 2 will be imaginary, so a came 1, okay. Then you have to apply RHL, okay, this you do yourself, I just leave here. When you apply RHL, it will be limit x tending to 0 plus 1 plus a cube plus 8 e power 1 by x upon 1 plus 1 minus b cube e power 1 by x. When you replace x by h, h tending to 0, it will be 0 plus h. 0 plus h, it means equals to 2 going on. 1 plus a cube plus 8 e power 1 by h upon 1 plus 1 minus b cube e power 1 by h equals to 2. Now here we have to take common, secret number 1, Rahasya 1. Now take common and then cancel. After that you will get again one relation between b and constant, you will get answer, okay. So here I am leaving, you have to try yourself, okay, try yourself.